This lesson is going to build upon what we know about slope and transfer it to rates of change. This big box on the top is just so that you understand very clearly that slope is equal to a rate of change. In fact, on the first day when we wrote down different definitions for slope, rate of change was one of them. Below this, we have a couple tips and steps for finding a rate of change. The first step is you need to locate two nice points on the graph. No different from what we did when we were actually calculating the slope from a graph. Second, you're going to count the rise over the run. The difference here with rates of change is that you must pay attention to the scale. And by scale, I mean not every graph is going to go up by 1, and you're also going to have to look at what type of units you are using for the rate of change. So our first example here is showing the distance that a train travels at a constant rate. So on the y-axis, we have distance in miles, and on the x-axis, we have time in hours. So the first thing we want to do is just locate two nice points. And we could probably just use 0, 0 as well, or we could go up there. So there's a couple of nice points. So the first thing we're going to do is just write down the rise and the run. So I'm going to count from that first point, and it looks like I'm going up 3 squares. However, don't write down 3. If you look at your scale, we actually started at 30 and we went up to 60. So we actually rose 30. I'd like you to put the units right along with this, so 30 miles. Now we're going to look at the run. And if you draw on the run, it's going to look like you're going over 4 boxes. So a lot of people would just write 4, but don't write 4. We actually went from an x value of 1 to an x value of 2. So the run is 1 hour. That makes our slope, or our speed, or our rate of change. In fact, maybe you should circle that word speed up there in the directions where it says find the speed of the train. And you should note that speed is just another word for slope, which is another word for rate of change. So our slope is 30, and that makes the speed of the train 30 miles per hour. And if you think about it the other way, if you had just done rise over run by counting the boxes, you would have said that your slope is 3/4. So your train would be going 3/4 of a mile per hour, and you'd probably be better off just walking, so you might just want to get off that train. All right, example 2. On the y-axis, we've got the rental cost in dollars, and on the x-axis, we have the number of videos. So here, you're going to start again by just marking 2 nice points. Okay, we're going to count the rise. The rise looks like you're going up 2 boxes, but again, you have to pay attention to the scale. So the rise here is actually 20, and that's $20. The run looks like you're going over 4 squares, but we actually went from 4 to 8, so we actually went over 8 squares, or 8 units, so that would be 8 videos. So our slope here is, or our rate of change, remember those words are interchangeable, is 20 over 8. So divide that out, and you can use a decimal here because we are going to be talking about dollars, so a decimal would make sense. So when you divide 20 by 8, you get 250. And we're going to write it like this because the rate of change, and here's where we answer the second question, represents dollars per video. So this graph is showing us that for each video we rent is actually $2.50 per video. Now you may notice at 0, if you rent 0 videos, your cost is $10. To you that may not make sense, but it's kind of like joining Netflix. You're going to pay a certain upfront charge, and then you're going to rent videos or rent things beyond that. So the initial membership fee here is actually $10 because when we rent 0 videos, it's still a cost of 10. All right, our last example is going to relate back to what we've done in class with the CBR and just kind of trying to match the graph. This one is going to require a lot of writing, so we're just going to slide this shade down so you can kind of understand where we're coming from. But as you're looking at your notes, you should write down everything that we have written down here. So the first thing we need to do is figure out what the origin is going to represent for us. So I just made this up, and I'm going to say the origin is going to represent the student's locker. It can be anything, but we just need a point of reference. So that's my first step. Then I notice here that I have a positively sloped segment. That means that the distance is getting bigger or getting larger as I walk here. So that means I'm going away from the locker. So the next thing I'm going to say is that the student began by walking away from her locker at a rate of 5/3 feet per second. Now you may wonder how I got that. I just simply counted the slope and did the rise over the run. And in this case, each box did represent 1 unit. So when you're talking about this path, you want to not only say they walked away, but you also want to talk about the speed. So they walked away at a speed of 5/3 feet per second. After that, we notice that we have a negatively sloped segment, which means that the student is walking back toward the locker. The distance is decreasing. Again, you're going to calculate the slope. We went down 3 and over 2. And here's where it gets a little tricky. We could put the negative sign in there to indicate the rate. But we could also say 3/2 because the speed that the person was walking was actually the 3/2. We took care of the negative by telling that we walked toward the locker. All right, next I see that we have a horizontal segment. That means that the student stopped. And when you say the student stopped, you want to say for how long. And in this case, you just count the spaces. Sometimes students will say 2 seconds because they're looking at the 2 grid marks, but it's actually just 1 space, and that represents 1 second. So we would just say the student stopped for 1 second. And then our last segment, again, is positive, which means the student is walking away from the point of reference, which in this case was the locker. And we're going to calculate the speed. And when we count the slope, it's just up 2 over 3. So the student walked away at a rate of 2/3 feet per second.